Welcome to Week 12, Part 1, Graph Exponential and Logarithmic Functions. So to review on how to graphing the exponential and logarithmic functions, we review on the characteristic of each function. We know that exponential and logarithmic functions are inverse functions. So you can see we always have 3 points will be in the graph, on the graph. And x and y of those points is switch or like swap for the functions. So we have exponential functions. F of x equal a is the base. X is the exponent. And then the graph f of x equal log base a of x, right? So we have the point -1, 1 over a. In this example, we have a equal 2. So we will have the point -1, comma 1 over 2. So find that point, -1 here. This is 1/2. Yes. Then we have the second point is 0, comma 1. 0, comma 1. Then we have another point at 1, comma 2. 1, comma 2 here. That 3 points on the graph. If a is greater than 1, then it's increasing. So you see that from left to right, it's go up at the end, right? So go up, so it increase if a greater than 1. F of x increasing. So in this case, a equal 2, so it's greater than 1. Yes, so f of x increasing. For other case, when a is less than 1 and greater than 0, f of x is decreasing. And we call it decay. This one we call it draw. And also, it will have the horizontal asymptote at y equal 0 or x-axis. The domain, you see that it could run this one for the horizontal. It runs from left to right without boundary. So it's from -infinity to infinity. For the range, it will be from, because it's the horizontal asymptote start at y equals 0. So it starts from 0 and then it grows, so it will be infinity. It's from here, go up. That the ring, this is the domain. Okay, so about the f of x equal log base a of x, we will have its opposite or inverse of f of x equal a to the power of x. So in this case, we use log base 2. So a still equal 2. And then let's see the point 1 over a is 1 over 2, comma, -1. Where that point 1/2 is right here. And yes. So that on the graph. And then another point, we have 1, comma 0. 1, 0. And then another point is 2, 1. 2, 1, right here. And we see that the same base, a equal 2, we have the inverse functions. Now we look at a equal 2, and that is greater than 1. So it's f of x increase. Then we have if a greater than 0, less than 1, f of x decrease. In this case, a is greater than 1, so f of x increase. We have the vertical asymptote. The vertical asymptote at x equals 0 or y-axis. And then the domain. The domain is start from 0. Let's start from 0 and go to the right all the way. So it's 0, infinity. For the range, it's go down deeply and then it's go up. So it's not restricted. The range will be from negative infinity to infinity. Let's try on this one. The question is f of x is 2 to the power of x plus 3 minus 5. So when we read the given functions, we know that f of x equal 2 to the power of x was the parent function. And that's how it looked like, the red line, the red graph. And now we analyze the negative 5 is go down 5 units. Because outside. And then plus 3 is go with x. So it will be go to the left 3 units. It could shift the whole graph down 5 units and to the left 3 units compared to the parent function. And to remind, y is as it is at what you look. Negative go down, positive go up. But for the x one, positive go to left and negative go to the right. So now we find the point. Here the point. Here's another point. Here's another point. That 3 points we have, right? And we have horizontal asymptote. Horizontal asymptote for the parent functions is at y equal 0. Now our new functions will shift down 5 units. So the horizontal asymptote now is y equal negative 5. New horizontal asymptote, y equal negative 5. Then the point, each point will be go down 5 units and go to the left 3 units. So 1 from this point go down 1, 2, 3, 4, 5, go down 5, then go to the left 3 unit. Okay. Now from this point we go 1, 2, 3, 4, 5, then go to the left 1, 2, 3 unit. The same for this point. Right, so we have 3 points with the horizontal asymptote. Now we can graph it. It's close to horizontal asymptote. Go like that. And we can find the y-intercept by plugging x equals 0 into the function. So we have 2 to the power of 3 is 8 minus 5 is 3. So y-intercept will be at point 0, 3. 0, 3 is right here. So we connect them, make them go up, up again until we cross that, and then we have the new graph. So to graph the functions, non-linear functions like that, we will have first step, we have to figure out what is the parent function. Second step, we know how it translates. Like, do it go down, go up? Do it go left, go right? Do it flip? And then number 3 is, can we find the y-intercept? Number 4, can we find some point to connect? And then we find out, how about horizontal asymptote, vertical asymptote? And then we can sketch. Connect all points. And sketch. Here's how the graph look like nicely. So we see that from that point, we go down to that. 5 unit down. Three unit to the left. Horizontal asymptote go down 5 unit. It's come from that. Horizontal asymptote go down. Because horizontal asymptote doesn't affect with the x, related to the x, so it's only affected by the y value, so it's go down 5 units. Horizontal asymptote go down 5 units as well. Okay, another example. So now we have the parent function should be h of x equal 3 to the power of x. And this is how it looks like. Now we see that it will be go up 2 units. So we draw horizontal asymptote up 2 units. That horizontal asymptote y equal to horizontal asymptote of the parent function is y equals 0. And then we have minus 5 is mean go to the right 5 unit. Right 5 unit. This one up 2 unit. We find a point, here 1 point. One 3, another point, right? And this one is 1/3, right? -1, 1/3. But let's do 2 point, the easy one to figure it out. So 0, 1. Now we move up 2 unit. Move up 2 unit. So 1, 2. Then we move to the right 5 unit. 1, 2, 3, 4, and 5. Maybe right here. Okay, that is 1 point. Okay, so for this point is where we go up 2 unit. Then go to the right 5 units, so it's far to the right. And for this one, this will be from 4, 1/3, and 2, so 2 and 1/3. So we can draw like that, right? Let's do green. Is horizontal asymptote close to that. And then we go through that point up. But the thing is, we haven't touched the negative in front of the whole thing. That negative is so important because it make the whole graph flip over the horizontal asymptote. So the final graph should look like this. Go down like that. Because of the negative in front. Here is demonstrate of what we're doing. For the first graph right here, we graph from the parent functions f of x equal x to the power of x. And then from that, we know how to graph the 3 to the power of x minus 5 plus 2. And then we flip over the horizontal line, y equal to get the negative in front. So The third one is the complete graph of the given function. Now this one is the decay because a, the base right here, a is 1/2 and is greater than 0, less than 1. So it's decreasing. F of x decrease. So now the parent functions is f of x equal 1/2 r to the power of x. The red line right here, the red graph. Now from that graph, we'll find some point. Here is the point. Nice point. Now we have to translate it. So we go +1, go up 1 unit, -4, go to the right 4 unit. So each of the point we have will go up 1 unit, to the right 4 unit. It become a point right here. We go up 1 unit, so it means the horizontal asymptote. This is horizontal asymptote of parent functions y equals 0. Now that will be go up 1 unit as well. Horizontal asymptote of the new one y equal 1. Now this point, we go up 1 unit, then 4 units to the right. This one, go up 1 unit, then to the 4 to the right. Now we can connect them. Close to the horizontal asymptote. Now also we have to find the y-intercept. Y-intercept, so 1/2 0 minus 4 plus 1. So 1 -4, 1 over 2 to the power of -4 plus 1 is equal to 2 to the power of 4 plus 1. That's 16 plus 1 is 17, so it goes really high over there. And how we do this one is 1 over 2 to the power of -4, that is 1 to the -4. That is 2 to the power of -4. When you flip, the negative power will be positive. So 2 to the power of 4, 1 to the power of 4. This one's 16 over 1, that's 16. So how it look here. So we move up 1 unit up. Four unit to the right. And the y-intercept is 17. 16 plus 1 is 17. Question 4. Now we wrap the logarithmic functions. So the parent functions of this is g of x equal log by 2 of x. Now we see it's go up 5 unit, to the left 4 unit, and we have the point right here. The point right here. And then we have the vertical asymptote. Vertical asymptote x equal 0. Now because we move to the left 4 unit, it means the vertical asymptote have to move to the left 4 unit as well. So we have the new vertical asymptote. X equal -4. Now we have this point have to be moved up 5 units. 1, 2, 3, 4, 5. And then we have to move to the left 4 units. 1, 2, 3, 4. So this is one point. Now the same as this. 1, 2, 3, 4, 5. Up 5. Then to the left 4. Now we can connect it. It's lucky because we don't have to find the y-intercept. It's on the rapid well. It's on the way we find when we using the translation. So the wrap will go down, close, and turn. Here how it look like. So we have from this point move up 5 units to the left 4 units. This point do the same. Then move to the right. I mean to the left 4 units. Vertical asymptote. At x equals -4. Okay, so for this graph, we know that the parent functions f of x is equal to log by 2 of x. And then this -5 is outside. So it should look like this. The x is argument of the log. And then -5 is outside. So this one is go down 5 units. Compared to the parent functions. So I find a point 1, 2. The vertical asymptote is VA. X equals 0. Now we have nothing to change with the x directions because it's the same as the parent function. So the graph just move down 5 units. So we move straight down 5 units. We have the new with the same vertical asymptote. We have 2 new points. We can find another point. It looks really nice here. 1, 2, 3, 4, 5. Then we can connect them. What is the importance of knowing what the argument of the log? If we have x minus 5 inside the parenthesis, it belongs to the log. So this one means we move to the right 5 units. That from the red, we move 5 units. Red graph, we move 5 units to the right. 5 units to the right, you got the green one. When we write like this, it means log by 2 of x and then we minus 5. That's what it means. So this one is log by 2 of x and then minus 5. So that minus 5 is go down 5 units. So from the red, we go down 5 units. We got the blue. And the result is the right graph. The number 2. Graph number 1 is just to compare. And it's important to understand the question. Alright, so for this one, parent functions f of x equal log by 2 of x. And then we move down 2 units. We move to the right 1 unit. And then we flip. So right here, we have 1 point. Right here, we have another point. Right here, we have another point. I try to find the point that at right intersections of each grid right here. So it's easy to count at the unit. So we go down 2 units, then go to the right 1 unit. That one. We go down 2 units, then right 1. Down 2, then right 1. We might have it look like that, right? But the dash purple line is the functions f of x equal log by 2 of x minus 1 minus 2. We still have to flip it. And how we flip it? We know that we have the vertical asymptote for the parent function vertical asymptote at x equals 0, but now you move to the right 1 unit. It means the vertical asymptote have to move to the right 1 unit as well. So here's our vertical asymptote. So it means this one have to be deleted. It have to sketch close to here. Here we go. But we have the negative and we need to flip it. So see, from the point right here, we flip it. So the point right here is x-axis, so we have the new axis at that point, translate here. That point translate here, here. That we have the new x-axis and we translate the point. So now we have to flip it over because the negative. So it will be go like that and then go up close to the vertical asymptote x equal vertical asymptote x equal 1. Now that point is the intersect of both, and then this point goes straight here. This one flip over, it's got this position because the distance between them is the same compared to that line right here. And at this point is perpendicular. If we connect 2 points and they intersect with the reflected axis, here how it looked. So we know that it's from this point, we move to that point. We got that. Then this is the axis of flip, right? We move 2 units down, horizontal. And then we move to the right 1 unit, down 2 units. So this is the point. Now we flip it over y equal -2 because we go down 2 units. And also we have the vertical asymptote at x equal 1 because you go to the right 1 unit. So the third graph right here is the final answer. Thank you for participating in this week's practice question. See you next time.